Hello, good morning, good afternoon, and good evening. Thanks very much for taking the time out of your day to join us. My name is Steve Zimmerman. I work for a company called Eline Media, and we've made a game called Beyond Blue. Beyond Blue is made in association and partnership with the BBC, and it features content that is both inspired by Blue Planet 2. Today with us, we are going to be asking the ocean, and so we've got a great collection of 3 scientific advisors that helped us out with the game. I'm going to go around the horn and have them introduce themselves, talk a little bit about their background and what some of their favorite ocean facts are. If you're just joining us and you are checking out the chat, you can say hello to Stephanie and Eric. They're going to be there interacting with you, answering some of your questions, as well as sharing them with me, so we can actually have our scientists answering your questions live. So first, let's start off with Dr. Mandy Joy. Tell us a little bit about yourself, please.
Hi, my name is Mandy Joy. I'm an oceanographer here at the University of Georgia in Athens, Georgia, and I study extreme environments in the deep ocean, from hydrothermal vents to brine pools. I'm really interested in astrobiology and life on other planets, and we use these deep ocean environment as analog sites for searching for really strange new types of life forms. Pretty cool.
All right, and then Dr. David Gruber.
Hey, I'm David. I'm here in New York City. I'm a marine biologist at the City University of New York and also at the American Museum of Natural History. I'm kind of like I guess like a generalist marine biologist, and I study everything from microbes all the way up to whales, and really interested in seeing the ocean from the perspective of marine creatures, as well as designing new kinds of robotic devices like squishy robot fingers that could be really gentle and delicate when we study marine life.
Okay, we'll definitely come back to the squishy robot fingers, I think, a little bit later on. And Anna Backer.
Hi, everyone. My name's Anna. I'm a PhD student here at the University of Miami's Rosenstiel School for Marine and Atmospheric Science. And I'm currently working on a PhD thesis that is looking at how we can monitor coral reef ecosystems around the world, but by using satellites. So usually people go and dive around these corals, but our team at the University of Miami wants to see how we can observe them by measuring things like temperature and wave energy and human population and how that is affecting their growth.
Great, thank you all very much for sharing some information about yourselves and for being with us here today. For those that don't know, Eline Media, when we make games, we like to put what we call insight videos into them. And these ocean insight videos that you'll find in Beyond Blue will be featuring the 3 individuals that we're talking with here today. So again, please make sure that you're asking questions into the chat, and then we'll be able to get those asked. To kick off, though, we have collected questions from various conventions as well as the internet across the last couple of months. And I think one of the first ones is one of the more fun ones that we can actually kind of put out there. And what is everybody's favorite ocean fact? And then for this, we'll go in kind of reverse order. So I'm going to give it to Anna first.
All right. I actually think that it's super interesting when you go diving in the ocean that all the color goes away. So once the reason for that is because the sun emits all wavelengths of color, but then only a certain amount of them penetrate deeper and deeper into the ocean. So as you get down a couple hundred meters, almost everything just looks blue, which is crazy. And a lot of animals have adapted very specifically to account for that.
So blue is one of the only color that actually penetrates down that far. It doesn't become almost like a black and white film or sepia toned?
It does not become sepia toned. I do not think so. I don't know if maybe there will be a place in the ocean that someone will discover it like that. But no, it's completely blue until there's no light anymore. And once all the light's gone, then it's black, pitch black down there. And that's where you start seeing animals that are making their own source of light since they don't have the sun.
Okay, I think we're going to come back to that in a couple of questions, I'm sure. David?
Yeah, I think, well, I agree with you, and I love that the ocean's blue. And I've been super thinking about what it's like for animals to be living in an all blue world. And our group has been looking at something called biofluorescence, where some marine creatures take the blue to create like reds and greens and oranges at depth. And we've been really diving into that, and recently even found a fluorescent turtle, which takes the blue light and turns it into green. So yeah, that's something I super love. I love so many things about the ocean, but I'll stop there for now.
Well, actually, we're going to expound upon that a little bit. And so a turtle that is, taking some of the blue colors and shifting it and things like that. As I understand it, you helped pioneer and developed a way to have us be able to see as some of those creatures are seeing. Is that picking up on the colors that has been focused down there? Or if you'd expand upon that a little bit more, that'd be great, please.
Yeah, let's think about how to unpack that. It's that, so like Anna brought up that when you go down below like 700 meters, like 7 to 9 of the animals that you, out of 10 animals that you find down there, are going to have this ability to like make their own light, because there's no light 24/7. So that's something called bioluminescent, where they're like a firefly, where they're making their own light. But what is happening in the upper part of the ocean, where it's still blue and where it gives it back off as another color. So it's almost like this secret inner portal to a world called the covert world of biofluorescence. And we found fish, and we found sharks, and recently found a turtle. And it's just blowing us away, because like we've been looking at these animals for all these years and then not realizing that there was this whole other like subculture, sub-world to them. And now we've been designing shark eye cameras and turtle eye cameras to kind of get at what it means to these animals. And we really don't know that much.
That's absolutely amazing. For those that have been following along in the game, it's one of the discoveries that David is talking about is something that we've actually integrated into it as well. As I understand it, it's one of the swell shark is one of the creatures that actually kind of has a little bit of UV to it. Are we talking about the same thing? Am I close?
Yeah, you got it. The swell shark is, I love the swell shark so hard, because it's like, it's this little shark that lives off the coast of California that nobody really paid attention to, because it looks like a pretty boring shark that's just like laying there. And it often gets mistaken for like an inner tube or something, because when they get excited, they'll gulp down water and swell up, and they just like will bite their tails. So they just look like a circular like inner tube. But even though they just lay there and they're not doing anything, we found out that they are actually really fluorescent. So when you put blue light on them, they turn green. And then we looked at their eyes, and then we looked at the males and females, and there were special little patterns among them. And even individuals have little patterns, like little stars in them. So it allows this really shy, like not a good swimming shark to be able to communicate with each other possibly. And yeah, that was one shark that I just dove so deep into, this little swell shark that is kind of like overlooked and sort of, considered boring, but now we've been like shining a light on that shark. That's so bad.
I think this is a pun-safe environment, so please feel free. And Mandy, your turn. What are some of your favorite ocean facts?
So I study extremophiles, and the average depth of the ocean is around 4,000 meters, and the average temperature is around 2 degrees centigrade. And those are conditions that most of us can't really imagine. But when we go down in submersibles, we can sort of see the animals living in this habitat. So I like to think about how organisms in the ocean adapt to these really challenging conditions. And I think most people don't realize just that's the average, cold and high pressure and very, very dark.
Well, and so just before we kicked off this panel, we were talking a little bit about, your love of extremophiles and things like that. And one of the things that we started getting into a bit more, and I would love for you to talk more about it, is I believe it was NASA's network of ocean worlds. And surrounding that, if you could kind of tell us a little bit more, that'd be great, please.
Sure. So NASA has long had an interest in extreme environments, and they have a exobiology and astrobiology program that's been around for quite a while. But in the last couple of years, they've put this new program together called NOW, Network for Ocean Worlds. And it's really aimed at bringing together, ocean scientists who are interested in, thinking about what kinds of conditions on other planetary bodies like Europa or Titan or Enceladus would promote life as maybe we don't know it, but could imagine it. And so it's a fantastic group, a lot of microbiologists, a lot of geologists and chemists and physicists, just thinking about how life could propagate and potentially thrive on some of these other worlds. And, my favorite to think about, I don't even know. For the longest time I was fascinated with Europa, but now, Titan and Enceladus fascinate me just as much. I mean, Titan has a sort of a methane ocean, which is just, mind-boggling to think about.
So these extreme environments, obviously, we're learning more and more about them, but are there, I mean, we're not obviously going to have a one-to-one comparison, but like where on Earth within the ocean are we finding out more? Like what are we looking towards to see and kind of possibly draw comparisons from? Like which environments does that exist in?
Sure. So there are deep ocean analogs for just about every imaginable extraplanetary extreme environment. For example, hydrothermal vents are one, brine pools are another. A lot of these extreme environments predicted to exist in other places are salty. They have high salt content, might be low pH or high pH, but they have high salt. Other places have their carbon dioxide springs on the bottom of the ocean, which are super acidic, and that's a good analog for some systems. So essentially, if you go around to the bottom of the ocean, either on continental margins or along spreading centers, you can find environments that sort of fit the bill and allow you to ask questions about life on other planets and ponder things of relevance to astrobiology. There are most certainly habitats in the bottom of the ocean that we have not yet discovered, and that have relevance to the kinds of questions that the Network for Ocean Worlds will study. And that's just another justification for doing a lot more deep ocean exploration, because really less than a couple of % of the deep ocean has been explored or visited by an ROV or a human-occupied vehicle, so a remotely operated vehicle or a human-occupied vehicle. And there's lifetimes worth of exploration to be done in the deep ocean.
Thanks very much. That's actually fantastic, and it kind of leads into a next series of questions that I'd like to make sure that we all have a chance to answer. Well, not me, but you're talking about sort of the vehicles and stuff and the technology that we're using to get down there. And David, you spoke about the shark eye camera, the turtle eye camera, and Anna, you're talking about like how you guys are using different technology to sense the coral reefs and take a look at things and kind of what that is. And so one of the questions that we picked up from Luke Leger, I hope I'm pronouncing your last name right, Luke, is what has been the most inspiring technological innovation in recent memory for marine scientists and marine scientists as well? And this is personal opinion only, of course.
I would say, maybe I'm biased just because I like to work with satellites, but just any kind of imaging has really taken off these past couple of decades. Like before, for example, if you wanted to observe like shallow water marine ecosystems, you would have to take a plane that had some kind of hyperspectral imaging on it and fly that over, back and forth and take all these photos and like put them together later. But now we can just rely on satellites, and NASA's even made like those small CubeSats, which are these tiny little satellites that you could launch up for super cheap and record data for a couple weeks, and then that's it. And they're super cheap to make. It's super easy to deploy, and I think it makes any kind of remote monitoring that you want to do of the ocean much easier and more accessible for any lab group.
Fantastic. Okay, so it's at least it's helping see more and get more people directly involved, even from a cost-benefit perspective, which is great. David?
I think one of the coolest things is just like getting humans to go deep underwater, and how new that is for us as like a species. That if a couple hundred years ago, if you dropped something in the ocean and it sunk like if it sunk 300 meters, it would be almost impossible for you to swim down and get it. So all these different ways in which humans try to figure out how to get underwater. At first, they try to put them in like a big pickle barrel with armholes and drop them in. This guy John Lethbridge in the 1700s into like the first diving bells, and William Beebe went a half a mile down in this crazy like steel sphere, and then into submarines and into the people that went in a submarine to the Marianas Trench, into Walsh and Picard, and now into like just the remotely operated vehicles and the new submarines. And then even on the diving side, like the scientific diving has gotten so much better, of not just breathing compressed air, but doing this trimix rebreather diving, so we don't use bubbles and we can get really close to the fish because they don't hear the sound of our breathing as much. So I just love the access and realizing that like a few hundred years ago, it was almost impossible for a human to do what we're doing.
So that's kind of incredible that we've actually come that far. For those that are at home, we don't advocate you diving with pickle barrels or jars of any kind. I just want to make sure that we put that out there now.
Check with us first.
Yeah, like this, leave the pickles to the professionals, I suppose. But Mandy, I guess same question for you, please.
So I think for the kind of work that I do, you know, advances in vehicle technology, whether it's human occupied or remote, has been huge. But the other thing has been the ability to create and develop sampling tools that allow us to, you know, not only go down into the bottom of the ocean in a submarine, or with an ROV, but to collect samples with integrity. So they're at in situ temperature and pressure and gas composition, because otherwise you're essentially taking the samples out of the environment and just altering them because of the differences in pressure, and they have nothing to do. I mean, by the time you get them on the surface and recover them, they're nothing like they were on the bottom. So, you know, collecting in situ samples and collecting in situ data is really important. And the other thing I think that has just been a game changer is the idea of establishing observatories where you can deploy instruments and sampling gear for long periods of time on the deep sea and in the water column, and begin to really understand the variability of these habitats and the dynamics of these habitats. And even better, you know, tracking how animals come in and out, how large animals come in and out. You know, like with acoustic arrays, you can track whale populations moving through an environment and a system, and sharks. So it's really exciting to see some of these data from these in situ observatories come in line, because we're learning a lot more about just the day-to-day, what it's like for the animals to sort of live in these habitats at the bottom of the ocean.
That's absolutely incredible. Kind of going back to submersibles and like life at the bottom of the ocean and how we can observe it, we do have a couple of questions that have come in. David and Mandy specifically, I know that you both spent time at the bottom and in the depths, and so we've got people asking about what's that like? How do you handle the claustrophobia? How long does that trip take on the way down? What are you looking for down there? How far can you see? And so if you could each spend a little bit of time talking about what that experience is like, because I think we've a certain number of people that we had landed on the moon. We've got less that have been down to the depths. And so I think people are kind of curious just about what that's like.
So I can take a shot first. It's a complicated process. I'll start with that. You don't just sort of pop your submarine into the water and land on the bottom, because if you do that, you land on a pretty boring place statistically. There's a whole series of events that has to happen. You've got to understand the geology. So to be a deep ocean scientist, you've got to be a little bit geologist, a little bit biologist, a little bit chemist, and a little bit physicist. So the geological mapping is the first step. Then you do towed cameras drops to sort of see whether what you think is there is actually there. And typically then you take a remotely operated vehicle. And then when you know there's something there that is really interesting, you get in your submarine and you take the submersible there and you see it with your own eyes. And for me, I can honestly say that I've never been claustrophobic. Once you get in the submarine, you know, you're looking out that window and you've got this bird's eye view of even the surface ocean is fascinating. All the plankton floating around and fish. I mean, once we were dropped into a school of tuna, and it was just there were fish everywhere, all around us, and they tracked us down to the bottom of the thermocline. And then you get to the base of the thermocline, and it starts getting darker and darker, and the bioluminescence kicks in, and you just lose track. You don't even have time to worry about being claustrophobic because there's too much interesting stuff to look at. I've never done a dive where I didn't see something that I had never seen before, and most dives you see something that no human has ever seen before. So it's really exciting and unlike any other thing you could do, because you know when you get into the sub that you're going to see something phenomenal that day, something that just sort of makes your jaw hit the floor and your eyes pop open, and leaves you breathless and at a loss for words. So I think it's really just a phenomenal opportunity to sort of experience the deep ocean in that way. And you know, I said once that I think if people who've been to the deep sea were given a choice, they'd want to dive every day, because it's been addictive, and you don't ever get enough of it, ever.
I believe there's a quote that I read of yours that it wasn't just you weren't destined to study the ocean, it was you were meant to be at the bottom and experiencing it in that way. Is that correct?
It is. And you know, it's a long story, but I'll make it quick. When I was a postdoc, I got an opportunity to go on an expedition with the Johnson Sea Link submersible. And, you know, the Johnson Sea Link had a big plexiglass sphere in the front, and the back was called the coffin because it was about the size of a coffin, and 2 people were in it, and it was really uncomfortable. And if you could survive that, then you were going to be okay. And when I went down in that submarine and they turned the lights on, and I looked out the little porthole, which was about this big, and saw this magnificent seascape around this brine pool, I knew that that's what I was supposed to be doing. You know, you search your whole life for what you're supposed to be doing. And when I looked out that porthole and saw that seascape, I just knew that's what I was supposed to be doing. And that's where I was supposed to be. So yeah, it's weird, and totally random that I ended up on that cruise doing that dive, but thank God I did.
I think we'll take the random, but I will disagree with the weird. I think it's actually the way that you describe it is actually a beautiful experience. And so thank you for even
my experience is not as brave. I remember the first time I went in a submarine, I went down in one of the Ocean X submarines, which is one of the partners in this game. And they have this really cool 3-person submarine called a Triton 3300-3. And I just remember, because as a scuba diver, I always just know like I'm in control and I could scuba dive and I could, you know, do things. But there was something about seeing that hatch go on over my head and like watching them seal this thing in that was like, oh boy, there's no getting out of this thing. And then when they were launching us, you know, it's like a big glass sphere and the waves are kind of rushing over the side. And I mean, my heart was just like jumping, you know, and I knew we were going to be in this submarine for a few hours, or like we could be in there for about 8 hours. And going down is pretty quick. We did this one on that same dive. We were looking for glowing animals, and we went down in the South Pacific on a place where I don't think any humans had ever brought a submarine. We went down to exactly where the water is 1,000 meters deep, and it's like 10, 11 o'clock at night, and we rested the submarine on the bottom, right at around 990 meters, and we turned off all the lights on the submarine because the driver of the submarine didn't want to turn all the lights off when we were moving, so we would, you know, bump into something. And we turned all the lights off. It's just waiting for our eyes to dark adapt, and we're running around the submarine, putting little duct tape over all the blinking lights. And then we put some jazz music on, you know, to kind of like just give this like ambiance, and sitting in the sub, nighttime, 1,000 meters down, and everything is like slow and viscous. And we put like a little bit of bait on the front of the submarine so it would lure things in. But then when we turned the lights off, it was just like it took about 15 minutes for our eyes to adjust. And it was like little blinky, glowy things and all the animals communicating with light. It was just magical, you know, to be there, to see these things. And every animal that I was seeing as a marine biologist, I was like, that's new. That's new. We've never seen that. And it was so almost like teasing to be able to see so many new creatures and not be able to, you know, identify what they are or interact with them. And that kind of led me to these like squishy robot fingers or ways to interact or set up a little laboratory on the front of a submarine so we could actually do science when we're parked at the bottom of the ocean in the middle of the night.
That's incredible. And just for everybody who's following along at home, it was a little bit of that story was the inspiration for a lot of the soundtrack that we actually have in Beyond Blue as well. It was, as I understand, it was the jazz Miles Davis.
I was, yeah.
So for those interested, we actually do have a full-blown soundtrack that is existing within the game because of stories like this and the interaction that we've managed to have with the scientists. I'll just take a quick moment again to kind of remind everybody, if you're hanging out with us in chat, you can have share your questions, your thoughts with Stephanie and Eric. They're monitoring the chat right now, and they're kind of feeding us up the questions. And so I do want to take a couple questions from some folks that we've got hanging out there. This is coming in from Captain Steve. I approve of the name, Captain. And so this kind of goes back into you're seeing things that both Mandy and David, that you've mentioned, that have never been seen before, and that like every dive is something new. And so there are certain things that we didn't think we'd ever see or see again. And please, you're going to have to help me out with the pronunciation of this one, guys. So Captain Steve asks, we found coelacanths? Coelacanths, living fossils, fish and krill shark. Do you think that there could be larger living fossils that exist down there? Because we've also just recently discovered the lobefish. So if we can talk a little bit about that and what they are and explain that to the audience, that'd be helpful too. Okay. I'm sorry,
I can take a shot since David's gone.
He'll be back shortly.
Yep. So given how little of the deep ocean that we've explored, there's a high probability that there are, and the fact that animals tend to run away from the loud props on the submarines and the lights, there's a high probability that there are things living down there that we have not yet found. I mean, the coelacanth story is a great example. They were thought to be extinct. They were discovered. I was actually in the Natural History Museum in London a few years ago and got to go in the back room where they have the first coelacanth that was discovered. It's in a big, it's a couple of almost 2 meters tall, and it's in this big, and there's the little note. I have a picture of it on my phone actually, because I showed it to my kids because it was such a cool thing. This student who was down there sketched this little fish, and it's like, oh, what does this looks like? A coelacanth? Could this possibly? And it was. So yes, you see things all the time that are moderately sized that just sort of give you a wow and go, oh, we don't know what that is exactly. So I suspect that once we develop technologies that are dark and quiet, we will start discovering a lot more in terms of big animals that live in the deep ocean who are smart enough to avoid us in our intrusive ways when we go down with our traditional tools, when we develop some stealth tools that sort of keep us embedded in the habitat. There's probably a lot more lurking there than we are aware of right now.
That's fantastic. And for those that are trying to be inspired by the game and this kind of conversation, that's the challenge that we put to you all. You can potentially discover the thing that is next, which would be amazing. Anna, we've got a couple questions that actually have come in surrounding your work with the corals and things like that. Basically, first up, somebody's asking, are corals living animals? So if you can take a little bit of time to kind of describe coral, what coral is, its life cycle and things like that. We also have, what's the lifespan, and basically give us a day in the life of coral.
Great. All right. So a coral is actually all three different things at once. So it's an animal, it's also a rock, and it's also a plant. And the reason that it is all of these things is it builds this really hard calcareous skeleton. So it's made of calcium carbonate, which it pulls from the seawater and builds over time. And it takes hundreds and hundreds of years to build a coral skeleton. So when you see a big reef that's still intact, it took hundreds of years to build that. So that's the rock part. And then a coral is also an animal because it has these little, if you go swimming over a reef and you went really, really close to a little coral, you could see, especially at night, it puts out these little polyps. They kind of look like little anemone tentacles, but those polyps are actually filter feeding particles that are, going through the water from ocean currents. So it has this little sticky membrane on the end of its tentacles, and it catches little particles, and then it sucks them in and eats them as food. But it also has another way of getting food, which is how it's a plant. So inside the coral skeleton, inside the tissue of where the tentacles are, it actually has these little algae called zooxanthellae. They're little dinoflagellates that are photosynthesizing. So kind of like plants do on land, and how they gather energy from the sun and make food for themselves. The algae that live in the corals are also getting energy from the sun. And then in exchange for having a home living on these corals, they give some of that food energy to the corals too. So corals have all those three parts, and they live for an extremely, extremely long time. And they reproduce in different ways. Like there's, in different parts of the ocean, there's different coral spawning months. So they'll release their eggs and sperm into the water, and the ocean currents will carry that around, and then the little coral baby can land somewhere and grow into a new coral that can reproduce that way, or it can like bud itself off into new baby corals right next to it. Very versatile animal, rock, plants.
It's all things. We had another question that came in that I think might be related to this, and you can tell me if it is or is not. It's, where does sand come from?
Yes, somewhat related. Sand comes from parrotfish eating corals. So actually, there are certain fish that are herbivores, which means they eat algae, and then certain fish that are carnivores, which means like maybe they eat other fish or shrimp and whatnot. But parrotfish are special in that they actually eat coral. So they'll go and like break chunks off of coral. And when they digest that coral, it comes out as sand. So not all the sand in the world is made out of parrotfish poop, but most of it is. I think they digest like a couple times a year of coral and turn it into sand.
Perfect. Thank you very much for the answer. Mandy, we've got two questions that have come in that kind of speak to, I think, something that you alluded to earlier. It was the relationship, well, one, and we can get to it, is, how salty is the ocean? And then are there places within the ocean that have got varying salinities, and why is that the case? And so we'll start there.
Okay, so most of the ocean has a stable salinity, and it's really interesting. It's called the principle of constant proportion. So all of the major salts in the ocean are always present at the same ratio, almost everywhere, except for places that millions or tens of millions of years ago where evaporite deposits formed. And when ocean basins open and close as the plates move around on the Earth's surface. Sometimes ocean basins are opening up, like the Gulf of California or the Red Sea. Those are juvenile ocean basins, baby ocean basins, if you will. There's hydrothermal spreading at the bottom of those basins, and they're opening up slowly. Hundreds of millions of years from now, there'll be full-blown oceans like the Atlantic or Pacific. And their basins, in that phase of evolution early on, you get evaporation on the edges, and you lay down salts, and there's an evaporative sequence of salts. It's halite, gypsum, and anhydrite. And when those salts form, you basically bury them underneath sediments, and later on, that salt is dissolved and it goes back up to the surface as a brine. And those brines can be on land, like in Mona Lake or the Great Salt Lake. Those are old brines. In Antarctica, they're the dry valley brines. There are these salt lakes of varying salinity, and in the bottom of the ocean, in the Mediterranean, in the Gulf of Mexico, and the Gulf of Cadiz. All over the place, you have brine pools, and every single one of those brine pools is unique. The chemistry is different. So you have these local hotspots of varying salinity that selects for very specific and unique types of life forms that can survive in that geochemical regime. That's why studying brines is so cool.
So no one is similar. It's very, like, the microbiology, I'm sorry, go ahead, please.
They're similar, but they're different. I mean, at a crude scale, yes, they're all salty, right? They're more salty than seawater, but some of them have gypsum-derived brines have high sulfate. Halite is just sodium chloride. So if it's a halite brine, it's just sodium chloride. If it's a gypsum halite mix, it'll have high salt and high sulfate. And sulfate is sort of is one of these keystone variables in the ocean. If you're an organism that can respire sulfate, you'd much rather be in a gypsum brine than a halite brine. So there's subtle differences that can sort of that the microbiology has to tune itself to, and the animals as well.
Okay. And speaking of subtlety and things like that, because obviously there are nuances that exist as large as the oceans are, like they are a delicate system. And so for both of you and Anna, in your study of, corals and things like that and what affects things, and Mandy, just basically the microbiology and how delicate these systems are, we've got a question in the chat from Nick Plays Stuff. And it's Nick is wondering how climate change affects currents, and have they or are they changing now and as we speak? So both of you can kind of maybe elaborate a little bit on that for Nick Plays Stuff, please.
So I can start, and then
Yeah.
one of you want to chime in, Anna? Go ahead, and I can.
I'm sure we're going to talk about the same thing, but I was going to say that one of the biggest ways that the ocean and the atmosphere are connected to each other is this thing called thermohaline circulation, or the global conveyor belt, which is just that in the poles of the Earth, like in the northern and southern pole, all the ice is melting, and then once that cold water sinks, since it's denser than the warm water, it drives this whole circulation that goes around the globe, like up to the tropics, and there it resurfaces, and that drives the entire climate of both the atmosphere and the ocean. And people are studying how this whole conveyor belt of water moving around the ocean has been weakened. It's just not as strong anymore, just because the world is warming up and it's not driving that circulation of water as strongly as it used to.
Yeah, and another factor that plays into that is the loss of ice in the Arctic and Antarctic. As you melt both, land ice and sea ice, land ice mainly, you're decreasing the salinity. And Anna mentioned before, it's thermohaline circulation. So the temperature of the water matters and the salinity of the water matters. So deep water in the ocean is formed by this sort of temperature and salinity signal. And in the North Atlantic, where the majority of the deep water forms and is sort of where this thermohaline circulation is initiated, it's driven largely by this combination of temperature and salinity signal. And so you've got really cold water that is salty and sinks. And in the Antarctic, you have cold water already, and it gets super salty and it sinks because of the excess salt. So anything that alters the temperature and or salinity signature is going to change the sort of the speed at which this conveyor belt is throttling. And the big problem that we have right now is that it appears that in the North Atlantic, the formation of this deep water is slowing down because the water is fresher and it's warmer. So it's not as cold as it needs to be, and it's not as salty as it needs to be to sink. And that's a big problem, because this is not something that we can fix, right? We can't go up there and make the water colder. We can't make it less salty. This is a result of global climate change, and it's something that we're already seeing indications that currents around the globe are shifting because of the alterations in this thermohaline circulation. Okay.
Bit of a sober topic, but we do have obviously a couple more questions that'll fall within this. I think there is the dawning realization that the health of the planet is directly linked so much to the health of the ocean. And so we've got Dashiell asking, what is each of your biggest environmental concerns for the ocean in the future? And then what steps do you believe we can take as a species now to help mitigate some of those impacts and start potentially, if possible, reversing some of the things?
I think that one of the biggest things that you can do is, especially if you're aware of these kinds of issues, is just tell your friends and family. I think that's like getting the word out there of how you can help, like, because doing the work yourself, like trying to use reusable bags, or, saying no to straws. That's really great. But then another thing that you can add on top of that is just telling your friends about how much you care about the ocean, or how much, you've heard about these things that you can do. But if you just spread the word about that, that's, I think, one of the biggest things that we can all do collectively.
Yeah, I agree. And I think, being a good example, setting a good example for others, and learning, facts and information that you can share with other people. I mean, plastic is one of the biggest problems. By 2050, there will be more plastic in the oceans than fish in terms of mass. And that's just, as somebody, I've been doing deep ocean work for 25 years, and 25 years ago, when you were in a submersible dive on the bottom of the ocean, I did see human refuse. I remember the first thing that I saw in the deep sea that kind of just made me go, oh my God, was a refrigerator that somebody had clearly shot with a shotgun multiple times until they sank it. So people would just go out there, throw it over, and then they just do target practice, and they sink the refrigerator. Now what you see is plastic, and more plastic. Mylar balloons. If I had a penny for every Mylar balloon I have seen on the bottom of the ocean, I would probably have a lot of money. I mean, a lot. They're just everywhere. In the water column, it used to be very rare to see, plastic floating around in the water. Now you see it every dive you get in the water, you see plastic. Getting plastic out of your life can't happen soon enough. We're surrounded by it. It's very difficult. But don't buy any new plastic. Find a bamboo or some other sustainable alternative. The other thing is just, understand your personal carbon footprint, and make, try to make changes that can improve your carbon footprint, and then tell your friends about it. As Anna said, communication is a big part of this. I think that, a lot of the changes that we have to make as a species, as a global community, are going to depend on, essentially, making your friends feel a little bit bad about their habits, and holding everybody accountable, and to a standard that is way up here as opposed to down here. And, there are a lot of websites where you can find information on what you can do to sort of improve your carbon footprint. Water footprints are also really important. I mean, when I first calculated my water footprint, I was a little bit astonished. Carbon footprints always blow you away, but water footprints are even, a bigger deal in some ways. So it depends on where you live, obviously. But just try to live in harmony. I mean, when you think about how we got where we are now by being disconnected with the natural world, by not being aware of what our impact is on the natural world. So I think everybody has to the first step is understanding what your impact is, and then the second step is minimizing it, and the third step is telling everybody else what you do to get to that point.
Definitely thoughtful answers from you both, and we really appreciate you speaking about it. If speaking of your carbon footprint and your water footprint and your impact, are there places that you would recommend, or resources or references that people can check out? And then we'll make sure that we post those up in the chat as well.
Sure, I can send you some sites. There are websites where you can calculate your carbon footprint. Some are better than others. I think there are places where you can calculate your water footprint. There are certainly resources that tell you what the water footprint of, say, different foods are. You hear this thing, eat less red meat. Red meat doesn't just have a huge carbon footprint, it has a huge water footprint. And the further up the food chain you eat, is the larger the carbon and the water footprint. But water footprints, it takes a tremendous amount of water to generate, say, a cow. And eating lower on the food chain it's much more responsible in terms of both carbon and water. But I'll shoot some links to you to post.
That would be great. And then we'll be sure that we share those out across some of our social channels so people can stay informed and involved. Kind of a slight pivot shift and a bit of the questions that we're getting, but you talked about finding Mylar balloons and a fridge that has shotgun blasts in it. I think one of the reasons that we want to make sure that we're preserving our environment is for this next question. And I know both of you have spent a significant amount of time underwater, and some folks would like to know, what is the most beautiful thing you've seen down there?
I would say the most beautiful thing is when I went diving, cold water diving, not super, super cold, but in Seattle. Everyone is super excited about, you know, diving in Australia and like the Southeast Pacific. But I think cold water diving has been the most amazing because you see so many different types of algae and like crazy big fish. But the most beautiful thing that I saw was in Seattle. They have these anemones that are super tall. They can even be maybe like 2 feet tall, and they're pretty big. And you can just see fields of white anemones in, you know, like super dark, murky waters. And it's just so beautiful because they look so weird, and you would never see that anywhere else. Like you just never see a field of white anemones laying around, but you can like swim through these all over. And then sometimes there's, you know, large fish hanging out near them. I think just the weird stuff that you don't think is underwater is the most beautiful for me.
Great answer. And Mandy?
For me, it is hydrothermal vents. The hydrothermal vents are these just spectacular deep sea ecosystems. But the thing that always sort of just blows my mind is the color. You know, in the deep sea, I get this question all the time: why is it so colorful? And I was on the Schmidt Ocean Institute expedition last year on the Falkor, and somebody, you know, on a live stream of a dive, somebody typed this question in, and I'd never been able to really come up with a good answer to this question on the fly until that day. And the answer is that metals. It's those colors come from these bioactive enzymes that have metals in them. And, you know, you say life is chemistry. Yeah, but really life is metals. And these metals give color to these organisms. And I don't just mean, you know, red, because blood is red because of hemoglobin. It's not red. It's pink. It's purple. It's yellow. It's all shades of orange. It's just like, you see all these different sort of just, and it's bright. It's so bright that it knocks your socks off. So you sort of come around one of these hydrothermal edifices, and it's just colorful. It's like a coral reef, except it's on the bottom of the ocean, and it's in the dark, and it's really just enigmatic that it's so colorful, but it's just as colorful as a reef on the surface. And that always just blows my mind. But it all comes down to metals and chemistry.
Fascinating, because I don't think that's something that a lot of people would think about. I know that I most certainly wouldn't, but it's metals and chemistry that are giving the ocean color. So again, we've got a bunch of questions here. I want to make sure that we're actually hitting a few of them. We've got one from Jinjar247. So, is there any specific moment in your career or education that you'd consider your biggest wow moment? Perhaps something that you've seen or experienced, something that you perhaps achieved as well. That's for both of you.
I can go first. So I think my biggest wow moment was starting graduate school, because this is kind of when I knew this is going to be the real beginning of my career as a scientist. Because I always grew up, you know, really loving the ocean. I really wanted to be a scientist, but this means that it's actually it. That I'm here being able to study the ocean and network with other people who are studying the ocean. It feels really real now that this can be my life. And it's just amazing that I could spend the rest of my career doing something that I love, and something that I've loved, you know, since I was a little girl. It was, yeah, starting grad school is really fun. It's very hard, but really fun.
So I think I've already sort of told you my wow moment, and that was when I was on that first submersible dive, and the lights came on, and I saw that amazing brine pool, you know, seascape. But I always have those wow moments on every expedition. There's something that you just sort of, it brings you back down to earth, and it's sort of humbling to realize, you know, we go out on these as a scientist, you're supposed to know things, right? You have to have all this knowledge so that you can think about new things and come up with new questions and answer these questions. And it's so exciting. But then you see these things that are so incredibly humbling, and you realize how little you actually know. And for me, that's the best part of being a scientist. It's realizing that I don't know the answer to that. But I want to know. And how do I find out the answer to that? And it's this process that you go through hundreds and thousands of times throughout your career, where you think you know all the answers, and then boom, you see something else. You go, wow, no, that is not right. I need to rethink that. And I think, my favorite part of this job is that I'm allowed to just ponder things and discover and learn all the time. I mean, that's my favorite thing about being a scientist, is learning and assembling information and creating knowledge. I think that's just one of the most powerful things that you can do, is create knowledge that improves hopefully humanity, but certainly improves our understanding of the Earth system. And if I can just make little tiny incremental contributions to that, it's a really rewarding part of my job is just sharing that knowledge with other people.
That's beautiful answers from the both of you. Thank you. Again, this is a reminder for those that are hanging out with us in chat. You can feel free to ask Eric and Stephanie some questions, and they'll make sure that they kick them our way, and we can ask our two scientists. David did have to step away. I know we sort of addressed that later. He could be back. Anna, this was something that we were talking about a little bit before we kicked off, and there are two questions that I think that you'll both be able to answer. But Anna, we've got Gavin, who is asking, why are ultra deep sea creatures so damn freaky?
Yes, I have an answer to that. So deep down in the ocean, since there's no light, there's no need for eyes. So a lot of creatures have either adapted very, very huge eyes to, let in as much light as they can, or they've adapted not having eyes at all. So either the eye will be very, very tiny or not even there. And then another strange thing that's happened to all the deep sea creatures is, because it's such a high pressure world, there's, so much water on top of you. They have very gelatinous bodies, which, we don't normally see. Like, when you think of fish, you think of the fish with scales that can swim around, but all the fish down there, don't really have any color. They don't really have any eyes. They're very jelly-like. Or they've, as David Gruber was talking earlier about how they've developed ways to make their own light. They have bioluminescence. So they've made a lot of really interesting evolutionary adaptations to live in such a high pressure world. And it's very cold down there, or if you're by the hydrothermal vents, it's very hot. There's all these very extreme environments that they've had to change in order to accommodate.
Okay, well, hopefully that does it for you, Gavin. Sort of speaking on deep sea creatures and stuff like that, we do have a question coming in from Dashel, and Dashel is asking, what's the deepest depth a multi-cell organism can be found at?
A multi-cell organism. So they found a lot of interesting critters at the bottom of the Mariana Trench that surprised quite a lot of people. So because they didn't think that fish could exist at such great depths. And when there was an expedition there just last year where they found a number of critters. There are even at these extreme, hydrothermal vents, living at this interface between super high boiling water and super cold seawater. There are lots of complex animals that are right at that interface. In fact, some of the most polythermal animals, alvanellids, their rear end can handle temperatures as hot as 50, 60 degrees centigrade, and their mouth can be out at 4 degrees centigrade. So they can't stand it for a long time, but they can stand it for a little bit. And a lot of animals that live in hydrothermal systems have to be able to handle shifting temperature regimes. Not boiling. They would get boiled to death for sure. But they live as close to that interface as they can, because the hydrothermal fluids, that's where all the energy comes from. So if you're living down there, you've got to sort of hedge your bets and live as close as you can and pray that you don't get barbecued by, you know, an eruption or event flow. So you'd be surprised. There are a lot of really unique and clever ways that life can evolve to handle high pressure. And I think we are just we've just skimmed the surface on high pressure adaptations and complex organisms. We don't really, a lot of that has been, you know, sampling problems. You got to get these animals up from those depths without an implosion, because a lot of the absolute pisophiles, they're adapted to high pressure, and if you bring them up in an unpressurized device, they just literally fall to pieces.
And that goes back to sort of what we're speaking about like, you know, some of the sensing and testing that we are doing in situ, right? That's, you know, fit into soft squishy fingers and things like that. We do have a question now from Yengai and Friends. And as scientists, what would you say is the best way to learn, educate, or experience for those that are not necessarily pursuing that path?
I would say going to even the aquarium or to a museum, because you get to interact with people, especially if you live in like a landlocked state and you want to, you know, see creatures that are in the ocean. It's a good way to just get a lot of information and be surrounded by, you know, exhibitors who are really interested in sharing all these cool facts they know about the animals. It's like, I think it's a good segue to, you know, see a lot of what's out there in the natural world. And then, you know, maybe you have a favorite exhibit that you always want to go back to. And then from there, like really spark your interest and learn more.
Yeah, I agree. You know, museums are great. Another way to really learn a lot about the deep sea is, you know, watch deep sea TV. The Schmidt-Ocean Institute's Falcor, the Nautilus, the Okeanos Explorer, the NOAA ship, they all do live feeds and telepresence. So you can watch exploration in progress from your house, and they provide a lot of information, you know, connecting you to additional readings or materials, and in some cases even putting you in touch with investigators that you can ask questions. So that's a great resource. There's a lot of online modules. The Smithsonian Ocean Portal has a tremendous amount of material available that you can sort of learn and explore things. And the American Museum of Natural History has an oceans exhibit. So does the Natural History Museum in London, and all that stuff is online, and you can access that stuff online. So there's a tremendous amount of material out there that even a non-scientist can easily digest and just, you know, learn, and then, you know, go explore more.
Perfect. Thank you both.
Off of the, Mandy was saying that we can look at videos, even just watching like nature documentaries online. Now there's so many. They're used to mostly, I don't know, when I was growing up, they usually were about like land animals, like the deserts and the savannas. But now I see so many that are coming about the ocean and the deep ocean too, just because now we have that technology to even be able to see down there, to go down there and film like bioluminescent animals down there. So you can do it right from your home.
This is where I'd be remiss if I did not plug the fact that E-Line Media is making Beyond Blue, which was inspired by and features a lot of content and footage from one of those documentaries, Blue Planet 2 and things. So more information on that in a second. But we have another question that came in from Billy Wild, who is watching right now. And do humans have any evolutionary leftovers from our prehistoric marine ancestors?
Do humans have any? So every once in a while, I don't know. I mean, do you know the answer to that? I think, you know, vestigial gills, but that's like an old wives' tale. I don't know.
Yeah, the only thing I can think of is I know that our arms are related to whale fins, and then maybe like the male nipples are related to, but I don't think that is in any of the ocean animals. That's all like land animals. It's a good question.
Yeah. Point to anything other than, you know, what Anna said. I don't know of anything really that is an obvious connector.
Okay.
Never seen a mermaid, so.
And to be fair, I don't know if you're looking at a manatee, how you would confuse it with a mermaid anyway. So we've got another question that came in from an Albert Wu. And this is a question for Dr. Joy. So we've got bases in Antarctica. We also have the International Space Station. Are there any plans by NASA to build an underwater lab? You mentioned earlier I'm sorry, it's now, I remember the acronym, but I can't remember the name.
Network for Ocean Worlds.
Okay, so do you believe that there's any plan to create like an underwater lab where we can actually do long-term science like has been discussed?
So Aquarius is not active now, but it was an underwater lab down in the Florida Keys that was active for some 20 years, I think. I don't think it's active right now, but that was shallow water reef work. But you did essentially saturated diving, and you lived down there in the habitat for, a month or two or whatever. I don't know that NASA has plans to develop an underwater, like a deep sea habitat. If they did, boy, would I ever jump on that. It'd be fantastic to have that opportunity. I think for now, a more realistic goal for, say, the next decade is to really establish deep sea observatories, because, one of the biggest challenges in doing deep sea science is trying to sort of wrap your head around the spatial and temporal variability that you need to capture in your work. Because we go down there in a dive, we might have on one expedition, if you're lucky, you have 20 dives. Most expeditions have maybe, from 10 to 14. And, so you have a very limited amount of time to do your work. So these, developing these observatories so you can have, long-term data sets is really critical, because that informs how you need to make the measurements and the time scale at which things, that you need to capture the natural sort of signal of the habitat. And we don't know what those time and space signatures are in the deep sea, really. And we know that some areas are much more dynamic and variable than others, but there are no deep sea observatories. We had one in the Gulf of Mexico between 2005 and 2010, and it was a short-lived program, unfortunately. And it's expensive to do that kind of work, and there really just hasn't been a program aimed at it. But it's critically important that things like that happen in the future.
This isn't quite a way to take measurements of the ocean, but one way to utilize the ocean, Microsoft is putting down they have already put down they're calling it like a data center, where so when you're using a bunch of supercomputers, it heats up, and there's a lot of energy being put into, cooling those data centers that we have on land. So actually what they've done is they've taken this giant crate and put all the supercomputers into the crate and then down into the ocean, because the ocean becomes very, very cold. Not that deep down. It'll actually, the bottom of the ocean, we were talking before, gets down to 4 degrees centigrade. So if they sink this data center down a couple hundred meters, they can do all the cooling, save energy on air conditioning, and use the ocean in a very innovative way.
Okay, thanks for sharing. We got one final question for each of you as we begin to kind of wrap this up. Again, I want to take a moment and say thank you for everybody who's participating in chat. I know that we can't get to all of the questions right now, but that doesn't necessarily mean that we won't do this again if everybody's having a good time with it. So we've got one more question, and then we're going to make a little bit of a surprise announcement regarding Beyond Blue. So for both Anna and Mandy, what do each of you believe that the future of the ocean looks like?
That's a hard question. So I think the future of the ocean depends on the decisions that we make in the next 5 years, because the sustainability of the ocean, from fisheries to the stability of thermohaline circulation, really depends on how rapidly we deal with global climate change. And by deal with, I mean reach a zero emissions world. And that is a tremendous challenge that takes a globally coordinated effort, and everybody is going to have to change the way that we live. And frankly, I think that the one thing that we can all maybe take from the coronavirus epidemic is that this is just, everybody's been staying at home, and it's so inconvenient to not go to the store and to do all these other things. But is it really? We're all going to have to change the way that we live. And I think we can either take this as an opportunity to foster change and to sort of reinvent and rethink the way we see the future and how we're willing to live our lives for the betterment of humanity, or we can just go back to doing everything that we're doing before. And I hope that we all take this opportunity to really rethink things, because by doing that, we are putting ourselves in a much stronger position to not just save the ocean and maintain ocean health and sustainability, but we're sort of making the whole planet a better place for everybody.
It was beautiful.
I would have to agree that where the ocean is going in the future definitely depends on how we act now. But I'm hopeful just because I think I see so many more people in the younger generations that are getting interested about the ocean. Like, no matter where they grow up, they like, everyone knows about the corals dying with like with increased temperatures. Everyone's pretty aware of that. And I think that will spark this whole generation of people wanting to protect the ocean and, wanting to preserve a better place for their kids and their kids' kids. So I think the ocean has a chance of looking very different from today in terms of like fisheries and what animals are there and the biodiversity. But I'm hopeful because a lot of people are still really interested in preserving and protecting it for the future.
Thank you both very much. This has been an absolutely enlightening conversation for me. I hope that everybody else there has been out there and following along and asking us questions has enjoyed it as well. We really do appreciate Anna, David, and Mandy taking the time out of their days to sit and chat with us. We do have the opportunity to do this again, so we'll potentially be looking at spooling this up once more and answering even more of your questions that you're asking. I am now very happy to announce that if you've been following along at Beyond Blue Game anywhere on social media or across the internet, that we are prepared to announce the launch date for PC, Xbox, and PlayStations of the game. It was going to be coming out on World Oceans Week, which actually kicks off on June 8th. So you've got only a limited amount of time left in which to wait for the game. If you've been following along for the last 2.5 years, we're very excited to bring this project to you. It features the amazing scientists that we've been talking to here today. And before we leave you, we just want to make sure that we're giving you the opportunity to check out the newest gameplay trailer before anybody else has seen it. So we hope that before we do that, everybody's healthy and well and taking care of yourselves. And then we're looking forward to having conversations with you all again in the near future. Thank you very much.
Welcome to the Western Pacific. I'm Dr. Mirai Soto, and I'll be your eyes and ears on this expedition. I'm joined today by two colleagues.
Hello, I'm Andre.
And I'm Irina.
First time on a live stream. Be gentle with her.
That's close enough. You can use your dive water to control the buoy from there.
I'm scanning to train our AI to recognize sperm whales, and so we can hopefully recognize our specific friend later.
Hello, Mirai. Thanks for checking in. Feeling settled in the sub?
I'm great. Nice suit, nice sub.
This solo sub test makes me nervous. We're definitely fitting it out for 2 pilots next time.
Didn't you help design it?
Yes, but now you're driving it.
Well, you don't see that every day. At least I don't.
Neither do I.
Looking good, Mirai. The Manta drone is ready for its first zoom scan.
All right, baby. We won't forget you now.
Great. I've been waiting for this. I have just activated your UV light. Now you can see what a swell shark sees.
That's what I'm talking about. Okay, this dive just keeps getting stranger.
I have something I know you'll want to see.